Five. So today we want to talk about functions. We said what is a function, and what we talked about a function being more than anything is where each x value is paired to only one y value, right? So if I take a look at the picture I have here, this graph right here at every particular x value only has one particular y value, okay? By the vertical line test, if it crosses through and never hits it more than once, anywhere, it will be a function. Yes, this is a function by the vertical line test. And this one, if I draw a vertical line down, hits it in more than one place, right? So this one's not a function because there's an x value that's got two y values. I guess this is not a function, okay? Now, I don't know what to say, okay? So again, what we want to talk about today is what is a function? And 9, 16. Okay, so definition of function. For every x value is paired to exactly one unique y value. So let's highlight that. It might be a test question coming up. It might be. So, there's an easy one. Okay, so here's my example. Why are functions important? Because if it's not a function, it doesn't make any sense. In our society, we have machines that do so much for us today that if it's not a function, a machine can't do it. I mean, if you ask a machine to do something, it's going to do a job, but it's not going to do two different jobs for one question, right? So it doesn't make any sense. So we want to make sure that whatever's the input, we get one output, all right? So here's my silly little example. I like this one. So you drive up to a latte stand today, and it's buy one for $3 and get one free, okay? So graph this, okay? So buy one, so I'm going to put one latte, two lattes. I'm going to go $3 as my $1, $2, $3, right? And if I wanted to graph this, then one latte costs me $3, okay? So I've got one input, or one x value, it's got exactly one y value, right? One latte is going to cost me $3. Now the second latte is still only going to cost me $3, but that's okay because it's still just, if I buy two lattes, it's still only going to cost me $3. It's not like two different prices.
Buy one, get one free.
Yeah, so two lattes is still going to cost me only $3, right? I buy the first one for $3. The second one is still just $3, right? So I've got, if I buy one, it costs me $3, Megan. If I buy two, it still costs me just $3, right? There's like not two different prices up there. It's just, $3. Now the other one though, and this is, yes, this is a function, yes, because each x value has exactly one y value. Each x value has exactly one y value. But now the second one isn't going to make any sense at all, okay? So you drive to the latte stand, order one latte, okay? So one latte, and the teller tells you that it's $3 and $4. So okay, well, 1, 2, 3, 4. There's 1, 2, 3, 4. So one latte costs me $3 and $4. Well, it can't be both. It can't be both. It can't be. Either I'm going to pay $3 or I'm going to pay $4. My choice, probably $3, right? So you can't have one x value with two different y values. It just doesn't make sense, does it? Here's another thing. We know with that vertical line test, if I were to draw a line, it hits it in two places. So if it ever hits the vertical line, if it hits it in more than one place, it fails the vertical line test. This is not a function. Every x value must have one unique y value, and that doesn't, okay? All right, example 3. Am I doing okay? Not going too fast? Okay, example 3. So these are x values, 3, 4, 5, 3, okay? And I got 2, 1. Is this a function? So one of the easiest way to do this is, if you don't quite get it, is make a graph. Let's just make a real easy little graph, okay? If it ever confuses you, you can make a graph, right? And then we'll go 1, 2, 3, 4, 5, right? And then we'll go 1, 2, 3. 3 goes to 2. 4 4 goes to 1, 5 goes to 3, and 3 goes to 1. Uh-oh, there's something wrong with that. Okay, I see a problem. So the value, the input of 3, this x value of 3 goes to 2, and this x value of 3 goes to 1. It can't go to both, can it? Can't go to both. So right here, you've got one x value of 3 going to 2 different y values. So it's not a function. So let's review real quick. What's a function? Each x value must have only one unique y value. If it has more than one, it's not a function, okay? So graphically, we can take a look at this. And in example 4, look at these 3 graphs and which ones are functions and which ones not. What do you think? First, second, or third? Which one of these are functions?
The first one's a function.
Good, I totally agree. And why do you know that, Megan? Totally right.
Because there's not 2 points on that line.
Perfect. And you can check by the vertical line test. You can do vertical, vertical. And Megan's right. There are not 2 points on any line, so this one's yes. This is a function. Yes is a function. Totally agree, okay? So this stuff's not that hard, is it? Okay, what do you think about the next 2? What about this one? This one's not, because it's going to fail the vertical line test right here. This x value's got 2 different y values, right? This is no, not a function. You've got one x value with 2 y's. What about the third one? It's not. It would pass, it's okay, but right here in this spot, it's not a function. Now, there's a way to make this a function. You can do an open circle here on this graph, and it would work, because if that was an open circle, I could pass through the open circle, and I'd hit this one, because an open circle means it does not have a point there. But I drew this one with 2 solids, so no, not a function. Okay, looks great, huh? How am I doing? Okay, turn it to the other side. Okay, all right. The chart shows pairing of coordinates. What needs to change to make it a function, okay? Well, let's just take a look at it. Is it a function? Yes or no? Is it a function?
3 and 1.
3 goes to 1. I agree with that. Does 3 go to any others?
No, it's a function.
Right? 5 goes to 0, right? Does 5 go to anything else?
No.
7 goes to 9. Does 7 go to anything else? 9 goes to 23. Does 9 go to anything else? So yes, it's a function. We don't need to make any changes. It is a function. Yes, is a function. Okay? Now, from the example above, list the domain and the range. Okay, now this isn't so bad. The domain. Let's go back to what the domain is. So in our reading, we said the domain was all input or all x values, okay? So we're just going to list them. So the domain would be, let's see, my 3, my 5, my 7, and my 9. Those are my domains. It's as easy as that. My domain are just the x values, okay? And my range, let's see what my reading says. All output are all y values, okay? So my range turns out to be just, you don't need to put in order 1, 0, 9, 23. Normally we would rewrite this in order. This is okay, but it probably would look better if we wrote it in order 0, 1, 9, 23. Both are the same. They both list the same members, right? Okay, that's it. Now, I did not put a lot down here. We have a half hour.
What?
We can probably get this done. You wait. Call it classwork.
You
Okay,
said
so call it classwork.